Good morning, Alice. It's the last day of the year, and I've got circle theorem number 5 for you. See if you can describe circle theorems 1 to 4. I should mention that there is no numbering sequence here, or no association between a given number. So, for example, one of the ones I've already mentioned is that the opposite angles in a cyclic quadrilateral add up to 180 degrees. That is not circle theorem number 4 or 2 or 3. It doesn't have a number. You need to be able to describe these using the description. There's no specific order. But the ones I've already talked to you about are that one, the cyclic quad rule, the one where you have the angles in a semicircle are 90 degrees. In other words, the angle made off a diameter is 90 degrees. Semicircle diameter, they refer to that particular type of chord, which is a diameter. Another one was that off the same chord, in this diagram here, the red line, off the same chord, two triangles made within the same segment, they make the same angle. So a brief version of that is angles in the same segment off the same chord are equal. The last one, what was the last one that I discussed? Oh, it was a tangent meets a radius at 90 degrees. That was the other one. This is the latest one. There's really just this and one other which form the core 6 theorems. There are a couple of sort of ancillary ones which sort of almost follow on from these 6. So this is this number 5, and 6 I'll do tomorrow. So number 5 here is, you can hopefully see from the diagram, the red line, as I've said, is a chord, and the blue triangle is to the center of the circle. The yellow triangle is to some other point on the circumference in the same segment as the center, if you like. And the rule here, as you can see from the black text here, is that the angle at the center is twice the angle at the circumference. Angle at center twice angle at circumference is the shorthand, quickest way of describing this. So angle at center twice angle at circumference off the chord. Normally these chords would have some letters. You might have, for example, A, oh, why can't I do that? A, here we go, A, B. These points would be labelled with some letters, A and B. So the way you describe this, let's say you were told that angle X was 60 degrees, and you asked to find the angle at the center there, maybe that's called Y or something. Then you would say angle Y is 120 degrees, because angle at center is twice angle at circumference of chord AB. That's it. So more of these when we meet, obviously, but these are just hopefully drip feeding these rules into your mind, so that you've seen them all and can recall perhaps a couple of them before we actually discuss the topic in more detail. But that's it. That's the 5th one. The 6th one will come tomorrow, and that's to do with tangents and chords. It's the most complicated one to describe and possibly to see as well, actually. But there's a building in complexity a little bit through this set of 6. Okay, so Happy New Year shortly, and watch out for my next one, last one, tomorrow. Bye now.